So to determine the interval of convergence, I'm going to use the ratio test to see if the series will converge, looking at the limit as n approaches infinity of the a sub n plus 1 term over the a sub nth term. Simplifying, that's the limit as n approaches infinity of x plus 1 to the n plus 1 over n plus 1 squared times n squared over x plus 1 to the n, which equals the limit as n approaches infinity of x plus 1 times n squared over n plus 1 squared, which becomes x plus 1. And this converges when the absolute value of x plus 1 is less than 1. So when x plus 1 is between 1 and negative 1, or when x is less than 0 and greater than negative 2. So to test on the endpoints, when x is equal to 0, that's the summation of k is equal to 1 to infinity of 1 to the k over k squared, which is the summation of k equals 1 to infinity of 1 over k squared. Looking at the nth term, the limit as n approaches infinity of 1 over n squared, so that converges. So then at x is equal to 0 then is included. So the interval then is x is less than or equal to 0. And then at x is equal to negative 2, that's the summation of k is equal to 1 to infinity. Substituting in negative 2 for x makes negative 1 to the k over k squared. Again, looking at the a sub nth term, limit as n goes to infinity of negative 1 to the n over n squared. That also converges. So then x is equal to negative 2 will also be included. So that's going to be x is greater than or equal to negative 2. So the series converges on negative 2 to 0, including negative 2 and 0. So which of the following sequences will converge? On the first one, using the nth term test, looking at the limit as n goes to infinity of 5n over 2n plus 1, which becomes 5 halves. So that sequence converges to 5 halves. The second one, looking at the ratio test, we have the limit as n approaches infinity of e to the n plus 1 over n plus 1 over e to the n over n, the a sub n plus 1 term over the a sub n term. So that's e to the n plus 1 over n plus 1 times n over e to the n, which simplifies to make limit as n goes to infinity of e times n over n plus 1, which is equal to infinity. So therefore that sequence diverges. And then the third one, we'll do a comparison test. So to direct comparison, looking at 1 plus e to the n is greater than or equal to e to the n. So 1 over e to the n is greater than or equal to 1 over 1 plus e to the n. Multiplying by e to the n over e to the n is greater than or equal to e to the n over 1 plus e to the n. So that means that 1 is greater than or equal to e to the n over 1 plus e to the n. So the limit as n goes to infinity of 1 is equal to 1, which means that that converges. So then the e to the n over 1 plus e to the n sequence will also converge. So the answer is D, 1 and 3. To determine what number the sequence converges to, look at the limit as n goes to infinity of the sequence, which simplifying becomes limit as n goes to infinity of 1/5, and then 5 plus n over 4 plus n all raised to the 100th. And that becomes 1 over 5 times 1, which is 1/5. Letter choice A. To find out when the series is going to converge, conducting the ratio test, looking at the limit as n goes to infinity, a sub n plus 1 term over the a sub nth term. Rewriting to have the limit as n approaches infinity of x plus 2 to the n plus 1 over the square root of n plus 1, multiplied by the reciprocal of radical n, x plus 2 to the n. So that's the limit as n goes to infinity, simplifying to make x plus 2 times radical n over radical n plus 1, which becomes x plus 2. And then this series will converge when the absolute value of x plus 2 is less than 1. So that's when x plus 2 is between 1 and negative 1, or x is less than negative 1, but greater than negative 3. So then to test the endpoints to see if they are included or not, when x is equal to negative 1, that's the summation of n equals 1 to infinity of 1 to the n over the square root of n. that's the summation of n equals 1 to infinity of 1 over the square root of n, which diverges. So x equals -1, it will not be included. And using x is equal to -3 then to see if that will be included, summation from n equals 1 to infinity of -1 to the n over the square root of n. That series converges, so x equals -3 will be included. So the interval of convergence is -3 to -1, where -3 is included, -1 is not.